Hello again. So this will be part 2 of this week's session on math skills. We have moved on from standard form and decimal, and we're going to go on to fractions, ratios, and percentages, and how to convert between those. So we will skip the niceties. We'll jump straight in. This is, I think, probably much more complicated than it looks. I think ratios, fractions, percentages, they're quite easy. As I said last time, they'll always give you nice numbers. They're not going to make it too tricky for you. So I'll just put my slides up. There we go. Right. So according to the spec, you need to know how to use ratios, fractions, and percentages, such as calculating them from tables. But also how to convert between them is a very useful skill as well, and that's something I'll show you how to do. We'll start with fractions. So when I started making this, I thought, that was a good intro. How do you define a fraction? I couldn't really find a good definition for a fraction. I mean, you all should know what one is: 1/2, 3/4, 2/3, etc. It's a way of expressing typically non-whole numbers, so not integers, for anyone who does maths, and by breaking numbers up into chunks of a larger whole. The common analogy is a pizza or a cake. So if you've got a pizza and you divide it into two parts, you have one of them. As a fraction, that's 1/2, one part out of 2. You call that a half. If you break it into 4 and you take 1, that's a quarter. You've got 1/4. If you take 22, you take 7, which is an approximation for pi, actually. That's 7/22 as a fraction. So nothing more arduous than that, but we'll have a look at some examples in a sec. Percentages, from the Latin cent, I think century, 100, expresses a value as a proportion of something out of 100. It could be a whole number, it might not be. You can have, and likewise, a percentage could be a whole number, it might not be. You can have a point of a percent. And if you had 10 students out of 100 who are left-handed, and I am left-handed, very proud to say, then you'd say 10% are left-handed. If you had 20 out of 200, that's also 10%. So you're just converting it as a value out of 100 rather than a raw score, because it's easier for us to conceptualize and organize data and information if it's in this more standardized format, rather than saying 387 out of 900. You've got to sort of do some mental gymnastics to kind of think about what that is, numerically speaking, proportionally. It's easy if it's just in a percentage. We all understand percentages, and they're thrown at us every day in the news, so they're easy to get a handle of. And you'll convert from fractions to percentages, and that's very easy to do with a calculator. Thirdly, ratios. So ratios, rather than showing you something out of a total, which is what a fraction is, so 3 out of 4, or percentages, 10% out of 100%. Ratios show you the relationship between two numbers, so the ratio of left-handed to right-handed, rather than the percentage of left-handed out of everybody. So, for example, random example, if we've got 17, 18-year-olds for sixth form college, and if there's 8 17-year-olds for every 6 18-year-olds, then you can express that ratio as a ratio of 8 to 6. From 17-year-olds to 18-year-olds, it's 8 to 6, and you express it as such with a colon between them. But you can simplify that, and we'll see how you can simplify fractions as well. You can cancel down if there's a common factor. So here you can see that both 8 and 6 are divided by 2. So 8 to 6 becomes 4 to 3, because 8 divided by 2 is 4, 6 divided by 3, 6 divided by 2, sorry, is 3. So you can cancel down quite easily. And I said I'll show you how to do the same with fractions. But what I'll jump in now is we'll go through an example together, and all being well, I'll put some examples together for you to have a go at that will go out with this session. And I'd like to reiterate again, maths is scary to a lot of people. A lot of people don't like maths. I nearly did my university dissertation on how much people don't like maths. So it's natural to feel that way if it's not your strong suit, but I promise you're not going to be asked anything completely scary. They will give you nice numbers. I'm sharing the wrong screen there. That is not my notebook. There we go. Oh, I'll share the right screen. Ignore me. Right, so let's go. Let's go have an example. Let's say we're looking at the proportion, well, not proportion, sorry, that's misleading. We're just looking at the numbers. Remember, this is what we said was standard form in the previous session, of psychology students in a sixth form who are doing certain degrees. Going with orange this time, so let me start my table. So we've got psychology, sociology, geography, history, and maths. And we've got the total number of students doing psychology at the sixth form as well, and that's 80. So 12 students are going on to do maths, 9 are going to do history, 3 are going to do geography, 16 are doing sociology, 40 are doing psychology, because psychology is the best, and I hope all of you are going on to do psychology degrees, because psychology is absolutely fab, and you will love it at degree level if that indeed is what you've chosen. But anyway, so let's think about getting this as ratios, fractions, percentages. So we'll convert all of these to fractions and all of these into percentages to start with. We'll do percentage first because I think it's a little bit easier, and then we'll do it as a fraction. So the way you want to get these into percentages is you just divide your number by your total. We're doing it in the same format as before. On the previous video, we're doing our smaller number. So it might say, what is the percentage of students who are studying sociology? Well, then we just take our smaller number, we divide it by the total. Remember, this is how we got the decimal form before. But then what we're going to do is we're going to times it by 100, because percentages are out of 100. And that is your percentage. So we're doing sociology, we've got 16, and we're dividing that by 80. So, I mean, I'm doing this in my head, but 10% would be 8. So we know 16 is double 8, so it's 20%. Timesing that by, or sorry, 0.2. And we times that by 100, that gives us our percentage. So 16 divided by 8 is 0.2. Times that by 100 is percentage. And that would be 20. So 20% are studying sociology. Okay, hopefully that makes sense. Let's do one of the other ones. So you just do this in your calculator. I'm doing it in my head. I'm showing you the work, and just so you can understand what's going on, what we're doing. But remember, you don't need to do that in your head in the exam. Absolutely not. So let's do maths. What percentage are you doing in maths? So we've got 12, and then we're going to again divide it by the total. Times that by 100, and that's your percentage. So 12 by 80, well, if I'm doing this in my head, 5% would be 4. So it's 3 lots of 5%, so it's 0.15. We're going to times that by 100 to get our percentage. So that is 15%. And it's honestly as simple as that. Honestly, as simple as that. They're not going to give you anything awful. I will show you a little trick though, and this is a life hack for you, not just a psychology hack. Let's say you're given something really that you don't like. Let's say you're asked to work out 7%, 25. And you think, I can't do that. That is too horrible. Never be able to work that out. 7 is such a random fiddly number. Never know what 7% 25 is. Well, good for you is that percentages are reversible. So the answer to this is the same as 25% 7. And that's easy to do. Usually one of these is easier to do. So we don't know what 7% of 25 is. No idea. But we know what 50% of 7 is. It's 3.5. We just divide by 2. And then we can divide by 2 again. 1.75. So you can work out 25% of 7 quite easily. You just divide by 2. Divide by 2 again. And this is useful if you go into an exam without a calculator. You get 1.75. So actually we know that 7% of 25 is 1.75 because we can just reverse the percentage and do it another way. Like here, we don't know what, well, let's say we want to know what 20% of 80 is. Now that might be a little harder to do. So we can reverse it and say, well, we know the answer is the same as 80% of 20. And then we've just got to divide by 5, which we know in our heads might, because you know a fifth of 20 is 4. And you just times by 4 again. Now you've got 60. Now I picked an example there where it's quite easy both ways around. But this one I think is a good example that if you do get stuck, you can reverse percentages. So it might ask you what's 18% of 50. And you might, yeah, let's do that one, 18% of 50. And you think that is awful to work out, so I've got no idea how to do that. Well, just remember that 50% of 18 is the same answer. And we know 50% is just a half. So we know that the answer is just 9. Makes it so much easier to work out when you know the trick. And that's just a little trick I wanted to share with you. So let's do these then. Let's go through them. So 40% of 80, well, 10% would be 8. So we're timesing that by 4, so that's 32. 32%. 10% is 8. Again, 20%. 3% of 80. You'll have to pardon me, I will need my calculator for this one. And forgive me as well, I'm not doing 80% of 3. But you could do that as well. So we're going to do 2.4. There we go. 9 is 11.25%, and 12 said is 15%. Because remember, you're just we know 5% is 4, so just times that by 3. That's 15%. So hopefully you feel okay with percentages now. You're just, as I said, just a reminder, you just take in the small number, you divide in that, or sorry, taking the small number, dividing it by the total, and multiplying 100. That's all you've got to do. Fractions. Fractions, you might find fractions easier, you might not be, but I think they're all quite straightforward. So for the fraction, we do what we did when we were converting. Well, we effectively we do the first step. We just take 40 for psychology and we'll look at dividing by 80. Because remember, when you do a division, you can express it this way. You can express it as a fraction. That just means 40 divided by 80. So here, when we're doing 16 divided by 80, we were just writing the same. So let me fill these in. So we've got 40 divided by 80, 60 divided by 80, 3 divided by 80, 9 divided by 80, and 12 divided by 80. So these are your fractions, and you might be thinking some of these can be simplified down. And that is exactly the case. We want to get these in the lowest possible value. We want the bottom number to be as small as it can possibly be. Now, these two jump out at me. These can't be simplified because no one number goes into both 3 and 80. 3 is prime, so only 1 and itself go into it, and 3 doesn't go into 80. So we can't simplify this any further. Same with this one. 1, 3, and 9 go into it. 9 doesn't go into 80, nor does 3. So these cannot be simplified. These are in their simplest form. But the rest can be simplified down. That's what we'll have a look at now. And remember what I said already about ratios. The way you can simplify them is just by seeing if they have a common number, dividing down. We turned 8 to 6 into 4 to 3. So we've got 40 to 80. Back. Make a new colour. Let's go red. 40 to 80. Now, if you don't feel confident, you can just divide this by 2. You've got 20 to 40, or you can see that you can divide again. So we again go down 10 to 20. You see that you can divide by 2 again, 5 to 10. Now, you can't divide by 2, but you can see that 5 goes into both 5 and 10. So we can take 5 out. That leaves you with a half. Alternatively, if you're feeling confident, you can just see you can take out a factor of 40 of both these. You can just go straight to here. Okay, so we know now that actually we can simplify this into 1/2. Now let's have a look at the second one. 16 over 80. Not quite as simple. Well, we can divide by 2 again, can't we? We can take a factor of 2 out, so that makes it 8 over 40. And we can take a factor of 2 out again. It's 4 over 20. Now we can still divide by 2. 2 out, 10. We can divide by 2 one more. And it's all the way down 1 over 5. And obviously what that means is you'll notice you could have just divided by 16. But again, the exam wouldn't expect you to do that straight away. You can just cancel it down in this one if you're more confident. I mean, use the page to your advantage, write your working out, just to help you organise your thoughts. So if you need to do it this way, absolutely fine. Don't worry about it. But we know now that this is 1 over 5. We know that 3 over 80 is already in its simplest form. So that just leaves us with 12 over 80. Again, I'd urge you to do the same technique. Divide by the smallest number you're comfortable with. It could be 2, it could be 3, it could be 4. So divide by 2, we get 6 out of 40. Divide by 2 again, we get 3 out of 20. Now, can that be simplified any further? Does 3 go into, can 20 be divided by 3? Can the bottom number be divided by the top? If it can't, you know you've reached its lowest form. And 3 does not go to 20. 6 times 3 is 18. 7 times 3 is 21. So we know it's in its lowest form there. So we can safely put this in. It's 3 over 20. That is correct. Now, you've also got to be able to convert between them. You've got to be able to take these and you've got to go from a percentage to a fraction and back again. So the easy way to go from a fraction to percentage is just do the division. So remember I said this is a division sign, and the formula for a percentage was the small number divided by the total times 100. Well, you've got your totals here. They've just been simplified, but the proportion from one to the top to the bottom is still the same. So to convert this into a percentage, you just do 1 divided by 2 times 100. And here we do 9 divided by 80 times 100. And that'll give you your 11.25 percentage. Very, very simple. You just divide the top by the bottom, multiply by 100. And if you scrap the by 100, that gets you decimal form. So if you just did 9 divided by 18, you get 0.1125. That's your decimal form. Just add on the times by 100 to get it to a percentage. So you can see it's quite straightforward. And just to get back the other way, we just go in reverse. So you know you've got 32% of 80. So we know if we divide by 100, we get the 0.32. So we just do 0.32 times 8. Times 80 equals 40. And we know the total was 80, so we know it's just 40 out of 80. And then again, you would just cancel it down as we did before. Some of your calculators might have a percentage, but I've never used them. I found them very fiddly. But that's how you go in both directions, how you convert between them. Okay. So for this, you just do one more actually. So we'll say we'll do 12. So 12% of 80. We know 15% of 80. We want to get that into a fraction. Well, we just we divide this side by 100 to get our decimal form, times it by that. That should give you your total number of participants who chose maths, and then you just convert it back into a fraction by just popping it over the total, and then you simplify this down as we did before to 3/20. Okay. Hopefully it's nice and simple for you. It's not as scary as it looks like. Numbers, they're not as terrifying as you might be led to believe, particularly on a psychology exam. But ratios are a little different. So with percentages and fractions, we're trying to find something out of a total. With ratios, we're seeing the relationship between two numbers. So we're not so much interested in the total here. We might want to know the ratio between sociology and history and maths. And the simple way to do that is if it asks you what's the ratio of psychology students who chose history to maths, well, you know there are 9 history students for every 12 maths students. That's all the ratio means. How many of A are there for every one of B? And like fractions, you just simplify down. So we know 3 goes into both of these, so we can just divide by 3. Ratio is 3 to 4. Simple as. 40 to 16. What's the ratio of psychology to sociology students? 40 to 16. There's 40 psychology undergraduates for every 16 sociology undergraduates, people who have chosen them out of our A-level cohort. So again, just simplify down. Well, we know 4 goes into both of these. We've already done that. So it goes 10 to 4, and we can divide again by 2, 5 to 2. So for every 5 people who select psychology as a degree, there's 2 who select sociology. It might ask you, there are 80 students. All of them took psychology. Well, it might say that 80 students. So let's have a look at something that's a little more exam. We've got 80 students. And it'll tell you the ratio psychology to sociology students is 5 to 2. And we know that this many students are doing geography, history, and maths. So how many are doing psychology and sociology then? This is probably harder than you'll get in an exam, but I want to be safe. So we know this adds 12, this adds 12, so we know there's 24 of these. Take 24 away from 80, you get 56. So we know that psychology plus sociology is 56. And we know there's 5 psychology students for every 2 sociology students. So what you do here is you add them together. Okay, so you add them together to get 7. What you want to do is see, you want to divide your 56, divide your total by 7. Pop that in your calculator, you get 8. Okay, and then just multiply. So you're doing the opposite essentially. You were cancelling down from 40 to 16 to get 5 to 2. What I'm saying now is when we're finding the ratio rather than from when we don't know the values, we do the opposite. We're multiplying up rather than dividing down. And that gives, and you multiply both the whole ratio by 8, you get your 40 to 16. So you work out how many students there are across psychology and sociology combined, add your ratio together, divide that total by the sum of your ratio, and then that gives you the number, you know how much to scale your ratio by. So that's harder than you'll probably get in an exam, but just want to give you everything just so you understand how ratios work generally. But I think the most you would be asked realistically is just to simplify a ratio, to identify something here. So it might say just what is the ratio of history to maths? As we said at the start, we know it's 9 to 12. Simplify that down. Divide by 3, 3 to 4. I honestly think that's the hardest you'll get. And you'll convert from a percentage to a decimal, or vice versa, or a fraction to a percentage, or vice versa. Nothing worse than that, nothing more strenuous. So hopefully that's given you a bit of a grounding in ratios, fractions, percentages, and how to use them. But you will be asked in a way that has you pulling something out of the table and simplifying it down or converting it, and that'll be it. It'll be simplification, cancelling down, or converting from one form to another. They're the 2 skills really I think you'll be asked on if you are asked a question like this at all. So hopefully that's helped you. So I'll put together a worksheet of just very simple ratio, fraction, percentage questions. Not anything like the one I showed you at the end there, where you're just trying to figure out the total number of psychology and sociology students from a ratio, where you have to calculate the ratio of the full number. Nothing that strenuous. But just for you to have a practice at converting and simplifying down. Okay. So that concludes part 2, and we'll be back with part 3 as soon as you like, thanks to the power of the internet, where we'll do rounding and significant figures.